What is solar water heating? Most people, when you say the word solar, think about solar electric. But actually, solar electric is pretty recent. Solar hot water has been around since the late 1800s and is much more proven and economical. It's very environmentally friendly to heat your hot water with solar. You can heat your domestic hot water. You can do space heating, which is heating your house. And you can also, if you have a spa, which has become more popular, you can preheat the water for the spa. And actually, about half of the solar hot water heating that's done in the United States is for pool heating. You'll see houses on the roof with a black mat and a pool in the backyard. And that's used to heat the water that's going to the pool so that they can extend their season and start earlier. So the people who are renting the vacation homes get more income because they can extend their season a few weeks. And the nice thing is sunshine is free. So for the life of the system, you don't have to pay. You're not paying any gas, electric, propane, or any other fossil fuel. So you're also saving the carbon footprint, so you're not emitting carbon. And that's environmentally friendly today. What are the parts of a solar hot water system? It's pretty basic. First, you've got a solar collector. The solar collector sits on the roof or on the ground. It's usually a 4x4 panel or 4x6 or 4x8. And there's also evacuated tubes, which is another type of solar collector. Most of the time around the Richmond and Virginia area, you'll see the solar panels because we don't need that hot of water. Evacuated tubes are more common for commercial applications. You have to have a storage tank. In our own homes, we have a hot water tank. It may be 50, 60, 80 gallons. And that is to store the water that the sun heats. And then you've got most systems contain a pump station. And the type systems I'm talking about today, I'm going to limit to Virginia. I'm not going to speak to systems that you might find in Florida or California or Alaska. There's a large variety of systems, but let's focus on our backyard. So these pump stations contain they are now ENERGY STAR rated. 20 years ago, we used to use pieces and parts. And it took time to assemble that. So this has become more of an appliance, just like your washing machine now. So you have a pump station. You also have a controller. The controller is basically a computer chip that checks the temperature on the roof of the panels, checks the temperature on your tank, and if it can get energy from the panels to heat the water, it will. Copper pipe. There's a lot of different pipe around today, PVC and PEX and all this, but the temperatures on a solar hot water system can exceed 160 degrees. So we generally use copper pipe on the loop between the collectors and the hot water tank. Inside the house, you're still fine to use PVC or PEX or whatever you've already got. It's not going to cause any problems because we have a device for safety purposes that limits the water temperature going to the house. It also extends the tank temperature because if we have 140 degrees stored in a tank and we're only delivering 125 degrees to the house, then that hot water lasts longer. We've also got a video tour prepared. Rather than bring this equipment into the room today and try to demonstrate it, we've actually gone out to a few of the sites in the area where we've installed equipment, and we'll show you the different components. So it will be a little bit easier for you. Here we are at a Habitat house in Henrico, Virginia. This was done this summer. These are two 4x6 panels installed in a landscape mode, not portrait like normally done. And these are up at a 60-degree angle. You can see they're elevated from the roof. And that's because we're using them to do space heating in the winter. In the front room, there's the front living room, there's radiant floor installed, and these provide heat in the winter to that floor. The plumbing on this is done. The cold water comes in on the bottom center of the panels. It goes into the front panel, and then it runs along to the back right hand side of the back panel and goes into the panels, goes through the panels and gets heated. Comes out at the top. You might be able to see it dead center. There's a air vent to vent air from the system, and then it goes down on the opposite end and goes down back into the house. In back of the panel, we probably can't see that, but that's the way the plumbing works. So it's installed in a closed loop. Okay, we're inside the Habitat house now, and this is the solar hot water tank. It's a large tank. It's 120 gallons, a little bit bigger than you might have a 50 or 60 gallon in your own house. Then it has a controller on the right hand side, and that controller right now says the roof is 121 degrees and the top of the tank is 116 degrees. And the systems contain an expansion tank because the water temperatures can vary quite a bit. You could go from 30 degrees outside to 150 degrees. So there's a pump station with this, which encloses multiple pieces and parts, the pump and numerous other items, which we used to install separately. It makes it a little nicer install package now. And there's a pressure gauge on the right hand side. These usually run around 25-30 pounds of pressure. And then there's temperature gauges which show you the temperature going up to the roof and the water temperature coming back. And the system has is equipped with an anti-scald valve, which is adjustable, and it controls the temperature of the water going into the house. The solar tank could get maybe as high as 140 degrees on bright sunny days, and we don't want that hot of water going into the house. So these usually set to anywhere from 115 degrees plus or minus 5 degrees. And that's the tank inside of the solar hot water tank. Let's go take a look at the radiant flooring in the house. This is what's used in the Habitat house for radiant heat in the floor in the living room. There is a cast aluminum plate. It stands up off the floor, the subfloor, and it has a pipe in it, PEX pipe, that is 3/8 inch, carries hot water through the floor, and that is conducted through the aluminum heat. The aluminum that spreads out, and then it penetrates. This is engineered plywood, 0.5 R, so it passes the heat through very easily, and it sits right on top, because in the Habitat house, this is normally nailed to subfloor, but they have a concrete floor, so instead of that we laid it on top of the concrete floor and applied some adhesive, and then put the flooring material right on top of that. These are interlocking panels that are pretty easily installed, and that's the subfloor. Now we'll go look at a different type of mounting for the solar panels. Okay, we're looking at the controls for the radiant system. There's a thermostat on the wall. You've all seen thermostats. That runs is connected to a DC transformer, which turns on a AC switch that powers our pump. The hot water comes up from the tank into the manifold here. We have a temperature setting which adjusts the temperature going to the floor. The pump delivers it to the floor, and then it goes out through these red pipes into the floor, and it returns through another set of red pipes into the manifold here, and then back to the tank again. So, and the radiant floor is right on the other side. You can see this is the hallway, and there's a slight rise up over the radiant flooring, and we'll show you that in another segment. Here we have a ground-mounted system. We have 4x8 panels. There's 8 of them in a row. The system is capable of producing about 500 gallons of hot water a day, 155 degrees right now. It's supported by, there's 2-foot concrete piling in the ground here, There's a 4-inch leg in the front which connects to a rail that holds the panels, and it runs the whole length of the system down to the other end. Then you see these poles in the back. They connect to another rail which is mounted to the panels that runs the whole length. These rear legs are commercial grade. They'll stand 130-mile-an-hour winds. Hopefully we won't see that around here. Maybe 70, 80, 90 with a hurricane or something, which we don't see very often. And then this, the output comes out of the top of the panel, runs down into the ground. And this is part of the Virginia Heat Store project, which instead of using hot water storage, we're storing in the tank, we're storing it in a solid medium, sand. So the closed loop goes into the sand. The heat store is 8 foot by 8 foot by 8 foot, so it's 15 cubic meters. And then there's a separate loop that takes the heat out of the heat store and transfers it into the house for space heating. So that's the Virginia Heat Store. First one in the United States, developed along with VCU. We're hoping to use it for affordable housing projects in Virginia. Well, through the miracle of electronics, I'm now out in Shenandoah. We're taking, give you a quick panoramic view of where we are. It's a beautiful view up here. And off in the corner here, you'll notice 8 4x10 foot solar hot water panels. They'll use to heat a pool, and the pool's up here in the corner. 100 feet away from the panels, there's a pool house, and then up here is the pool. It's a 3,200 gallon pool, pretty good size, and it's got a cover on it right now. We've had a lot of heavy rain. Go into the pool house for a minute, and we'll see there's the controller that controls both all the pool equipment as well as the solar panels. There's a pool pump down here in the corner, the pool filter system, diverter valve which routes the water through one of various channels, one of which is up to the heat exchanger, which is connected to the solar panels. There's a solar pump that runs a closed loop circuit, and a flow gauge tells us how much water is flowing through the system. And that transfers the heat into the pool loop, which goes down into the pool. And there's an expansion tank, which is standard. And that's a pretty good sized pool system. A lot of times down at the shore, you'll see systems that are used to expend the the pool swimming season up on the roof. And they'll a vinyl material placed up on the roof. I don't know if we'll get a chance to go over and stop at one, but they're more common down at the shore in this area. This system will heat the pool during the winter and allow the owner to swim during the winter time.
Actually, the first solar hot water was patented in 1891. Out in the western portions of the United States. It's about the time they started doing running cold water into the house, and it didn't take Mom long to want running hot water as well. So the very first solar hot water heaters was a simple tank painted black and enclosed in a case, and it was put up on the roof and the water got hot. And gravity fed the water to the kitchen or bathroom, wherever they were using it. Well, and it took a few years. In 1909, they actually found that it could make the water system better and larger by separating the tank from the collectors. So it started to look more like a system that we have today. Then about 1913, out in the West, they had a real cold spell. And if you take water on the roof and you get a cold spell, it does the same thing it does around here. It freezes. So it broke a lot of these systems. So out of that incident, they found that the system migrated to where they use a heat exchanger now. So they used antifreeze in a closed loop going between the collector and this heat exchanger.